Hello everyone, this is Ashani from Cheenta.com. In this particular video, we will discuss a problem from American math competition. This problem is a very curious mixture of geometry and combinatorics. Both of these are heavily tested in Mathematical Olympiads. If you are new to our channel, welcome. In this particular video, as usual, we will discuss a non-routine problem and we will learn something from it. Moreover, if you're interested in our Math Olympiad programs or Physics Olympiad programs or Computer Science Olympiad programs, check the link in the description for more details. So this particular structure is called a cube. A cube. Many of you have seen this before. All of its sides are equal. So all sides are equal. So without loss of generality, we can assume that all of the sides are 1 unit long. All of the sides are 1 unit long. This is a general strategy. Whenever you have all sides equal, to simplify the problem, you can actually assign a value to each of those sides. Okay, so we are assigning the value of 1 to each of those sides to make things simpler. And the question says, how many equilateral triangles can be drawn using the vertices of this cube? So these 8 points are the vertices of this cube. 8 points are the vertices of this cube. Question is this: how many equilateral triangles are possible using the vertices of this cube such that P is a point of that equilateral triangle? So let me write that: vertex. So they gave an example that PRQ is an isosceles triangle with P as a vertex. PRQ is an isosceles triangle with P as a vertex, and all 3 vertices are coming from these 8 vertices. That's how we want to make these triangles. The vertices of the triangles should come from the 8 vertices of the cube, and the triangle should be equilateral. So this example, the triangle is not equilateral. It's an isosceles triangle. In fact, by using Pythagoras theorem, we can easily check that the lines coming out of P, can be of 3 types. PR, which is a diagonal of a square, PQ, which is the side of the cube, and PU, which is the diagonal of the cube itself. So if you use Pythagoras theorem, which says that in a right triangle, length and breadth, or length of the square of the 2 sides, adds up to the square of the hypotenuse. So L square plus B square equal to 8 square. So look at this particular picture one more time. In this is a right triangle. This side is 1, this side is 1. So this side is square root of 2. You can calculate it using Pythagoras theorem. So PR is square root of 2. PQ is 1. And PU, that's the first challenge of this particular problem. So this is challenge 1. It's very simple. Challenge 1. Find PU. It's not related to the main objective of the problem, but you can find it. using Pythagoras theorem. So this is a challenge 1. If you can solve it, put it in the comment section. Let me see what you have got. Okay. So now the question is, we want to build equilateral triangles with P as a vertex. So let me draw one such equilateral triangle. So we will use the color pink, and I'll join PR, PV, and RV. Okay, let me delete the other lines just to remove confusion. So all of these sides are square root of 2 centimeters, or the square root of 2 units. So that's an equilateral triangle. It uses the diagonal of 3 squares, of which are sort of adjacent to each other. And of course, one of the vertices is P. So one of the square diagonals that is coming out of P produces one equilateral triangle. But actually it produces more than one equilateral triangle. What we could do is, we could have also taken PTR. PTR. That is also an equilateral triangle. Root 2, root 2, root 2. So corresponding to one diagonal coming out of P, we have 2 equilateral triangles exactly. So how many diagonals are coming out of P? Square diagonals. So one here, and one here. These are the 3 square diagonals which are coming out of P. Each of these square diagonals are producing 2 equilateral triangles. Each of these square diagonals are producing 2 equilateral triangles. One here for PR, right? The thing to realize here is that we are double counting. For each square diagonal coming out of P, you have 2 triangles, 2 equilateral triangles, but then you are double counting the equilateral triangles, because for PR you have PVR, for PV you also have PVR. In fact, so the same thing will be true for PT. Here is the second challenge, the challenge 2, and it is just one line from here. How many equilateral triangles are there with P as a vertex? How many? How many equilateral triangles with P as a vertex? Just make sure you understand the logic, the strategy that we used, because these are the little problem solving strategy. Double counting, using the length as a unit 1. All of these things actually come up in more stronger problems. So you should be able to understand what these strategies, little strategies are. Otherwise, you can just physically count the triangles. There is nothing to do. The purpose of this video is actually to help you understand some of the underlying strategies that could be used in a bigger and more stronger problem. So just to recap, each of the square diagonals are producing 2 equilateral triangles. There are 3 square diagonals coming out of P. But when we are counting the 2 equilateral triangles, we are actually double counting. So think about it and tell me in the comments section, just one line from here. Tell me in the comment section how many equilateral triangles are there coming out of the point P. I hope you liked this video. I'll see you in the next one. Thank you for joining in today. Bye.